They turn the vibrators on and the whole form shake. And all the air bubbles and all that from the concrete come up to the top and it smooths all the sides. Okay? If you leave these vibrators on too long, what happens?
Segregation.
Segregation of your concrete. All your stone. What's in concrete? Come on, you're the senior.
What, gravel or something?
Aggregate,
Okay.
sand, Portland cement, and water. And when you call, your mixture is, it's by weight, how many pounds of each one are in there. But if you vibrate it too much, all your aggregates and all your sand will go down to the bottom, and all your water and Portland cement will just stay in that one area. It'll be real smooth at the top, and on the bottom it'll look like somebody shot it with a shotgun. Okay?
Do you use any admixtures?
We use admixtures in here. We use self-consolidating concrete, so we can get away from vibrating. There's an admixture out there. You put it in your concrete, and you put it out there, and it just goes. It goes out it settles itself. Self-consolidating concrete.
So the one extreme is self-consolidated, and the other is zero slump.
Correct.
How do you go in between? What kind of
Zero slump concrete, you can take it, and if you dump it out of the bucket, it will. If you take zero slump concrete and take it in your hand and squeeze it, it will stay like a circle, the shape of your hand.
What kind of products you use for zero slump?
Typically, zero slump concrete will be used for hollow core flooring because it's put through a machine and it's pressurized and then it extrudes it out. So it doesn't need water, because if it has too much water in there and vibrates it, all the cores will collapse and everything else. With concrete like this, or in housing panels, we use self-consolidating because we don't want to vibrate it. Okay. This building is self-contained. It's heated during the wintertime. It has, as you can see, the electronic heating on the side of the walls, the radiant heat. This will stay about 60 degrees in the dead of winter.
So you work in rain, sunshine, or rain?
We work in rain or whatever because we pour inside. Here you can see some smaller sections of sound wall. And you can see on some sound wall panels we've built up the bottom because this panel only has to be 9 feet high. That panel has to be 13 feet high. So you can do your different heights by building up your form underneath it. The question was before about painting. And, all right, where's the door? That's a polyurethane. In this room, I'm not going to take you in there right now, but in this room we have 4 painting bays. We can take the product out of the form, put it on the A-frame, bring it in that room in 20 degree, 10 degree, 5 degree weather, bring it inside, and then paint it before we bring it outside. Because most paints are stains that require 50 degrees and rising before you can apply it. That's how we get it. Keep going that way.
What's this for?
Yeah, this is actually this is a reinforcement that they're requiring in the sound wall. They wanted epoxy coated stirrups. That's what you see, a stirrup bar like that. With the hard bend. And they have not come back and touched this up yet, because when you can see them touching the epoxy up, it looks like a darker green.
Do you use any welding at all?
No. No.
For the rebar?
No.
Excuse me,
Question.
question. What are these called? I know that they're used to tie them together.
Those are rebar ties.
This rebar ties?
Yeah, that's what they're called. They're called bar ties in the industry. Those are epoxy coated, but because you can't use a standard black rebar tie, which is just carbon steel, on epoxy coating, because there'll be a chemical reaction. You use epoxy coated ties with epoxy coated bars. You can use carbon steel ties with galvanized, and there won't be a reaction. Why is the blocks on top of that? What they're probably doing on that is making an impression in the piece below, and if you don't put weight on it and you pour the concrete, it'll lift the form up. So they put extra weight on there to keep the thing down. That could be for window frames or something else like that too, because if you don't put it flat on the form, they'll call that lifting out of the piece, and you'll see the frame in the form like this. So you weight it all down.
But like you don't want it to stay in there for too long?
No. What they'll do is when they strip this form away from it, they take the blocks of concrete off first, and then they take all the forms away from it.
And then they stand it.
Then you stand it up. Yep.
Also, if there is no weight, the concrete, when they're pouring concrete, has a chance to slip through.
Yeah, but there's probably something in there that they're holding down to the face of the form. And if that's not there, when you lift it, remember, concrete is poured and it comes down with such force, it'll lift stuff off the bottom. This is a system that, this is a patented system that we're working with the inventor. And this will actually go underneath roadways. Right now in cities like Chicago or other places like that, they're replacing or they're widening roads. And what happens is they dig the road out, and these big bundles of electricity and phone lines and all that are in these big, huge cables. And unfortunately, when they put them in there, they didn't mark them. So they might have a bundle with 100 cables in there, and they don't know where they go to. So typically what they have to do is they decommission the entire line, they put up a temporary alongside, and then they have somebody come in here and take this line and tap it and say, okay, that's phone, and mark it. This one is a fiber optic, this one is cable. We were working with an inventor that instead of messing around with that, take these concrete pieces and encapsulate over that big bundle of cables, and then build your road on top of it. Saves time, saves money, and things like that. This is a design by an engineer who has patented it. We are thinking of, we're hopefully taking this throughout the entire United States. It hasn't even hit the streets yet. So it's confidential. No more pictures. No. A form like this will be replaced after one pour. You know, we try to do whenever we can use steel because it's reusable, recyclable, and things like that. But realities, some of these pieces are not uniform in size. Exactly. Because once you pour something in concrete, you have to start watching, because this stuff will all start delaminating from each other. Put your hand on here, folks. What, you feel it? It's still curing. Concrete, when it's curing, gives off heat. You take this stuff in the dead of winter, you bring it outside, you see smoke just flying off this piece. Because the natural reaction of the Portland cement and everything else, yeah, I know. Some people may want to lay on this now because you're too cold. Yeah, we can take this off in 16, 18 hours. And this concrete right here will be about 3,500 PSI. And as you'll see, cylinders like this, every single piece of concrete will have at least 4 of these. And then when they break them after 18 hours and say, okay, now you can pull the piece out of here. If they don't get it in 18 hours, what happens? They'll break it in 24 hours. This piece will sit in the form until the quality control department says it's time to go.
Do you use any accelerators at all?
Yeah. How much? I have no idea. Depending on the weather, depending on... Exactly. Yeah, I'm getting too long here, folks. Yeah, they're probably not asking Andy any questions.